Hello and welcome. Today I'll be talking about Webpack 2. So what is Webpack? Well, in short, Webpack is a module bundler. So over here we have a file index.js that's going to be our entry point. And it depends on two modules, module A and module B. And they both depend on module C. And what Webpack is going to do is Webpack's going to take those, create a dependency graph of them so it knows what all the dependencies are within our modules, and then it's going to output a bundle.js file. So let's see how this is done with a basic example. So I'm going to use Atom, and in here I just have a folder with another folder called assets inside of it. And I'm going to go ahead and create something, a folder called source. That's where we're going to put all of our JavaScript. And I'm also going to create a package.json. And inside my source directory, I'm going to create two files. So one called index.js and the other one called message.js. And finally, I'm going to go ahead and I'm going to install Webpack as a dev dependency. Alright, so while that's installing, let's go ahead and get our index file set up. So I'm going to import one of our message from our message module. And it's just going to be a function that says hi. So we're going to import that function and then we're going to execute it. And then over my message module, I'm going to create that function. And we're going to console log hi. And now we can go ahead and we can export it. Say hi. There we go. Cool. So if we go over to our package.json now, we can see that we installed Webpack 2.2. That's perfect. That's what we want. We want to use Webpack 2 for this. So I'm going to go ahead and I'm going to create a script called build. And all this is going to do is it's going to run Webpack. And when we run Webpack, by default, it's going to look for a file called webpack.config.js. So let's go ahead and let's set that up. So in order for Webpack to read from this, we need to use common JS module syntax. So module.exports. And in here is going to be an object with two parameters on it. One is going to be our entry point. And in this case, it's going to be index.js. So that's going to be where Webpack looks to import all of the other modules. So that's our bootstrapping file. And then we have output. So output is going to be an object, and it's going to contain two properties. One is called path. That's where we want our output to go. In this case, we want to put it to a build directory. And the file name is typically going to be bundle.js. So that's going to be our bundled up JavaScript code. Great, so let's go ahead and run that script that we created. So npm run build. It's going to run Webpack. Webpack looks inside this config. And we see that we created this bundle.js file in a build directory. I'm going to zoom this in, just make sure you guys can see everything. Okay, so inside this bundle, let's see what we get. So up here we see a lot of stuff that isn't ours. So this is all what Webpack injected. Down here, however, we can see that we have an array of modules. So the first one, index 0, is going to be, that is our message module. And then down here, this is our, this is the index. It looks a little bit different, but this is the index module. So we can see that we actually require in, so this is our import statement essentially. So this is requiring index 0. And this is it executing that function, that hi function. You can see say hi right here. Great. So up here, what Webpack injects is two things. So one, it injects stuff related to caching. So if we have multiple, we wouldn't want to be using the same module over and over. Instead, we'd want to cache it and then just use the cache version. And then we have some stuff here related to support for different types of module syntax. So there's ES6, CommonJS, etc. All right. So one thing to note is that we're using this const and we're using arrow functions, and this is all ES6 syntax, which is one of the newer versions of JavaScript. Unfortunately, not all browsers support this yet. So we can get around this by actually using what's called loaders. So I'm going to use a loader called Babel Loader. And Babel is it's a transpiler, and it's going to take, for us, it's going to take ES6, and it's going to transpile it to ES5. So how it looks is we import the ES6 code, and we're going to test, is it a JavaScript file? If it passed that test, we're going to pass it through Babel Loader. Babel Loader is going to go ahead and transpile it. It's going to output ES5, and it's going to place that in our bundle. So in short, these loaders, they take in the file source, and then they return that transpiled source before it goes into our bundle. So we can go back over here, and I'm going to install a couple things. I'm going to install Babel Core. Babel Core is Babel's core compiler. I'm going to install Babel preset ES 2015. That's letting Babel know how to transpile the ES 2015 syntax, or in other words, ES6. And finally, I'm going to install Babel Loader, so that's Webpack's loader. And while that's installing, let's go ahead and set this up. So we can add another property here called module, and it's going to be an object, and it's going to contain this property called rules, which is an array. Each element in this array is going to be an object, and inside the object, that's where we're going to put our loaders. So in this case, we want to use the Babel Loader. And remember, we need to kind of run this test. Oops. We need to run the test to see if it's a JavaScript file. So we can do that with the regular expression. So we can do, oops, make sure that it ends with the JavaScript, that it's a JS file. All right, so if I run this, it's not going to work quite yet. One thing we need to tell Babel to do is we need to let Babel know kind of what syntax we're using, so that Babel knows how to transpile it. So in this case, we're using ES 2015 syntax. So we create this file called babel.rc or .babelrc. And when Babel runs, it's going to look inside here and kind of look at the config that we set up. So in this case, it just presets an array. So we could, like, if we had React in here, like JSX syntax, we could let Babel know, hey, we're also using React, so it knows how to transpile that. But for our case, we're just using ES6 or ES 2015 type. All right, so I'm going to go ahead and I'm going to run build. And if we look in here, we should see, yeah, so everything is now transpiled to, you can see that it's var, say hi, where over here we have a const. So this is now the ES5 syntax. Okay, perfect. So loaders are basically, that's going to pre-process your code. So that's pretty cool. So let's take a look at another example. I'm going to create a new file here called image display.js, and it's going to have two functions. We're going to have, we want this file to display some images, so we're going to have display cheetah, and you're going to see up here in our assets we have a cheetah and a sloth image. So we're going to have display cheetah, and we're going to have display sloth. And we're actually going to go ahead and we're going to install jQuery, because we're going to start using writing some DOM code, writing HTML. So jQuery is a nice little library that we can leverage. And we're going to import jQuery. we go. We can access the body, body equals body. We're just pulling it out of our HTML, which we haven't created, so let's go ahead and do that now. It's going to be a very basic HTML file. I'm going to do HTML body and then script source. Well, we want to use the JavaScript, our bundled up JavaScript, so we go into build bundle.js. All right, so here I need to have we have cheetah image, and that's going to be image. So again, using jQuery for this, and we're going to give the source, and then cheetah. We want to append it to the body. Just go ahead and copy that. Same thing for the sloth and the sloth image. Okay, so for the source, this is going to be where's our actual file coming from. So with Webpack, it's more than just JavaScript that you can use. So you can actually import image files. You can import CSS, HTML, etc. So we can actually go ahead and import sloth from assets sloth.jpg. In this case, we do need to specify the file extension. For JavaScript files, we get that for free where we don't need to. And cheetah from assets/cheetah. Now Webpack doesn't quite know how to deal with these images. We can import them, but Webpack just knows how to deal with JavaScript. So let me finish writing this, and then we'll see what happens when we try and run Webpack. So we're going to export these, and finally in our index.js we'll want to use them. So import display sloth image display, and then we'll execute those functions. Okay, so if I go ahead and I run build, remember I said that Webpack doesn't know how to deal with images, just knows how to deal with JavaScript. So it kind of blows up, which we did expect. But if we look here, we see that we are getting kind of a hint as to what's going on. So we can say that it failed here, but then it says you may need an appropriate loader to handle this file type. So what we're going to use is we're going to use two different loaders. We're going to use, so we're going to use something called image webpack loader, not img loader. It's going to be image webpack loader. I'm going to use URL loader. So how it's going to work is we're going to import our image. We're going to test to see if it is an image. So in this case, is it a JPEG? If so, we're going to pass it to image webpack loader. And what that's going to do is that's going to compress the image for us. So URL loader, so since these can be chained together, URL loader is going to get that compressed image. And URL loader's responsibility is to determine if that is a large or a small image. And if it's a large, it's going to load it as a file. And if it's a small, it's going to include it as a data URI in our bundle. All right, so let's see how that's done. I'm going to go ahead and install as dev dependencies image webpack loader and URL loader. And while that's installing, we can go ahead to our config, and we can create another object here. All right, so we're going to test, and we want to make sure that these are JPEGs, or that they're images. So in our case, we're only using JPEG, so that's all we have to test against. You can see they're both a JPEG. And we want to specify a use property. So we can say, so this use, by the way, it's going to go from bottom to top or right to left. That's how it's going to execute. So for our case, we want to execute URL loader last, so we put it first, and then we want to execute image webpack loader. But if we go back here, you can see that we have URL loader needs to actually have some logic in it. So it determines if it's a small image or a large image. So we need to tell it what a small image is and what a large image is. So we can actually specify some properties here, or give it some arguments. So instead of it being a string, we can make it an object. And we can say our loader, it's going to be the same thing as use. They're basically interchangeable. So our loader is URL loader. And then we're going to give it this options object. And options is going to have a limit of 3,500, 35,000 bytes, or 35 kilobytes. So in other words, anything that is larger than this is going to be included as a file. Anything smaller will be a data URI. So I can go ahead and run the build. Looks like, yeah, this should work. npm run build. And let's see what happens. All right, so it looks like it ran. And if we go ahead and show this, we can see we've got this JPEG and we've got our bundle. So what happened was the large image is now here. So the large image in this case was this sloth. So we can see that that was included. So this will be loaded as a file. And we can see that it's 64.48 kilobytes. And let's look at the original. The original is 350 kilobytes. So we can see that our image Webpack Loader did compress it nicely for us. Now, what happened to the other image? So the other image for us, that ended up being included as a data URI. So we can see here that this is the actual image of the cheetah. So that should help save us by including it in our bundle. That will actually help save us on the HTTP requests, which should give us a nice little performance gain. All right, so now at this point, I should be able to open my index.html. And we see just the cheetah. So what went wrong? Well, let's go back. And one thing we should notice is that we put that JavaScript file, ended up going in the build directory. And if we look at the error, well, it looks like it's just looking at our root. So what we can do is we can tell our loaders to append something to all the URLs that they create. So we can tell them to append a certain path. And in our case, the path is going to be build. So we want all of our loaders to append the build path to all the URLs that they generate. And if I go ahead and I run the build, and we open the index.html, now we can see we got both the images. Awesome. All right, so let's look at one other thing. So loaders that we can see right now, they're almost like preprocessors for our source, and they're chainable. So they end up taking in the source file. They do some processing to it, and then they return it so that another loader can actually pick it up, or if we want, we could just include it in the bundle. So I'm going to go ahead and I'm going to require in something called Webpack. So Webpack comes out of the box with a couple nice things we can use. One of them is optimize. And I'm going to introduce a new concept called plugins. So plugins will allow us to, if loaders can allow us to pre-process code, well, plugins are going to allow us to actually do some post-processing on our code. So we basically, after that bundle gets generated, the plugin will be able to transform that code. So Optimize comes with a UglifyJs plugin. And what this does is it will uglify and minify our code, and we can specify certain arguments in here to tell it how to do it. But for right now, we're just going to leave this empty. And the reason it has to be instantiated is because we can actually apply the same plugin with multiple different like parameters. So we need to instantiate it. And let's go ahead and run the build. So right now we can see our bundle is 287 kilobytes. And UglifyJs should take care of reducing that pretty significantly. Awesome. So we see that now our bundle has gone down almost a third. So it's now at 100 kilobytes, which is a pretty significant reduction. And there's more arguments we can pass in here if we want to get it even smaller. So that's great. Okay, so let's kind of recap here. So main ideas. Webpack is a module bundler. It's basically going to take your JavaScript and it's going to output it into, basically a bundled up file. The entry point, that's where, that's kind of your bootstrap file. So that's where you would start kind of like with your other import statements, etc. So for us, it was index.js. So index.js is going to import all of our other modules that we're using. For output, that's going to be where our bundle ends up going. So in our case, we ended up using the build directory and we put a file in it called bundle.js. Loaders. So loaders are the preprocessors for your code. Loaders, in our case, we used the Babel. We also used, so the Babel Loader, we used the image webpack loader and the URL loader. And they allowed us to do some kind of processing on our code before it ended up going into our bundle. So in the case of images, for example, Webpack doesn't know how to deal with images. It just knows how to deal with JavaScript. But the loaders allow us to actually take that image, process it, and then include JavaScript in our bundle. And finally, plugins. So plugins are, a lot of times they're post processes for your code. So in the case of UglifyJs, we saw that UglifyJs will minify and uglify our bundled up file. And that was done as a post-processing job. Plugins in reality, though, they're much more powerful than that. They can do pretty much anything a loader cannot do. So plugins are given access to the entire compilation lifecycle. So they can, they're basically very powerful. All right, so right now we've been going over primarily production type code. So let's take a look at how we use Webpack in development. So Webpack comes with something called webpack-dev-server. And this is very useful when you're doing development. So it allows for, pretty much out of the box, it allows for something called live reload. So if I run, so I create a start script, which is just going to execute webpack-dev-server. And if I run this, what it's going to do is it's going to put all of our modules into memory. And anytime we make a change to our code, it's going to notify the browser of that change, and our browser is going to go ahead and reload itself with the new code. So if I go ahead and I do npm start, let's go ahead and let's take a look at, let's get this going side by side. So right now we can see that we start up a server at localhost 8080. So we can go to that. And we can see our code there. And let's go back to index.js and let's take out this display cheetah function. And remove it from there. And you can see that our browser is automatically refreshed. So this is live reload kind of in action. So that display cheetah is completely gone. The browser knew, okay, the code changed because the server informed it. So it's going to go ahead and refresh itself. So that's pretty cool. But Webpack also comes with something called hot module replacement. And in order to get this running, we're going to create another script called hot. And we're going to do webpack-dev-server with a couple arguments. I'm going to do hot and inline. And to get this set up, I'm going to create a new module, and I'm going to call it, module.hot.accept. So we're going to say that this new module, which I'm going to call hot, will accept hot module replacement. So hot.js. All right, so I've got this. So in my index.js, we're going to import that module. Okay, and what this is saying is that any changes to this hot.js module will be considered, basically we won't use live reload for them. Instead, we'll actually be using hot module replacement. And hot module replacement actually allows us to maintain the state of our application and just reload or replace certain modules in it, which is really neat and very powerful. So I'm going to say .text is adder. So here what I'm doing is I'm just creating a very simple module. I have this adder variable, and we're saying this line here is saying I accept hot module replacement. So I, as you know, my module or myself, I accept hot module replacement. This line over here in index.js that says my module dependency, this hot, that accepts hot module replacement. And if I go ahead to index.html, I'm going to create a paragraph tag. P. There we go. And remove the space. Okay, so let's see what actually happens now. If I go ahead, we're going to close this out and we're going to run hot before we're running start. And we're going to open up a new browser. Okay, so we can see here that we are displaying the text 22. And if I go ahead, I'm going to open up the network. So normally when we go ahead and we make a change in a module, so let's say we make a change over here, we say hi with an exclamation point, we save it. Webpack-dev-server is going to treat that as a live reload. So it's going to go ahead and it's going to reload our bundle.js, it's going to reload our image, all this stuff. Now if we go back over here, and we can clear this out, we go back over here and we change this module and we say adder is now 25. We can see that we did not do a full page refresh. Instead, we just changed that one module, which is really neat. So let's go ahead and let's see how that works. So HMR is just short for hot module replacement. And when a hot module has its file changed, Webpack is going to compile it, and then it's going to inform the HMR server. And that's our Webpack-dev-server. Webpack-dev-server, or the HMR server, is going to open up a WebSocket with the HMR runtime. HMR runtime is included in our bundled up JavaScript. And when it goes ahead and informs the HMR runtime that a change was made, the HMR runtime is going to request that change via HTTP. Then that change is going to come in and our code is going to update. So you can see here, make that change, and you'll notice that just this module gets replaced. And this is actually pretty cool, and we can end up taking it a step further. So inside here, we can add some logic. And by default, I'm going to go ahead, I'm going to make this bigger again. So this module.hot, that's going to come with a data property on it. And when it initially comes in, it's undefined, so we do need to kind of add like a safety check for it. But I'm going to say if data.adder, and this will make sense in a second, adder equals data.adder plus adder. And we're going to go ahead and say module.hot.dispose. Oops. Data. And we're going to say data.adder equals adder. Okay, so I just wrote a lot of code, so let's go ahead and kind of review what this is going to do. So this module.hot.dispose. So when I make a change to this file and I click that save button, this function is going to execute. So this is almost like kind of like your destroy function before that page is going to, before you're going to get that like reload. And in this case, we can do any sort of cleanup we want, but we can also go ahead and save state to this data property that we get. So in this case, right before I kind of like get my new module or my module gets replaced, I'm saving the state of it. So I'm saving the state of this adder. And that's what's going to happen is this page is going to, or this module is going to get replaced. It's going to initialize it to 28, but then we're going to come in here. And what we're going to do is we're going to do a safety check because this, again, when you first initialize it, it's not going to be present. But if it is present, if this data.adder is present, we're going to say adder equals the old adder plus our new value. So let's see exactly what that means. I'm going to go ahead, restart this, and we'll go here. We'll get these going side by side again. All right, so now you can see that we've got the value of 28. So if I say 5, this is not going to turn to 5, but instead what we're going to do is we're going to take the old value and add it to our new value. So this, if I save this, this should be 33. Perfect. So we can see that we can actually maintain or save state kind of in between, you know, like when we refresh our code or change our code, which is really cool. You could imagine for debugging, you're going through, you know, some nasty bug where maybe you have to do a whole bunch of preparatory work to reproduce it. You know, maybe it takes a long, maybe you have to fill out a full form or whatever. And it's just kind of tedious. What HMR allows you to do is save the state after you make a change to your code. So you don't have to keep changing your code, wait for the page to refresh, get it back into its state, and then kind of repeat the process. So it's a really powerful concept, kind of neat. All right, so now that's basically, if we look, so the main ideas for development are, we've got webpack-dev-server, and out of the box we basically get live reload. That's pretty cool, and that's going to allow us, anytime we make a change and we save our code, it's going to go ahead and it's going to notify the browser. The browser is going to do a refresh, and we're going to have that code updated. We can see it on the browser. Hot module replacement, so that's the one that we can just replace the modules that we want to. We don't need to do a full page refresh, and we can actually keep the state of the application. All right, so let's go ahead and take a look at our next example. So I'm going to go ahead and close all these tabs just so we don't have all this clutter. I'm going to open index, and what I want to do is I want to dynamically load a file. So you could imagine that somewhere in our bundle here we've got code that displays a button, and when that button is clicked, we want to go ahead and load some other page. Now, we don't know if the user is going to click that button or not. So we wouldn't want to include this other page and its contents in our bundle. We don't want to add that excess code if we don't need it, right? So this dynamic loading is going to allow us to load the JavaScript only that we need, which is pretty cool. So I'm going to create a new file here, and I'm going to call it button.js. And inside button, we're going to have a function called display button. And we're going to import jQuery from jQuery. And we're going to create a button. And we have a source. Oh, sorry, not a source. We want text. And we'll say, don't click me. And we want to add this to our body. So, and we're going to say button.append to body. All right. And one thing we want to do is on click. So for jQuery, we have a click function. On click, we want to load some file, right? So Webpack 2 actually supports the ES6 standard for importing, which is system.import. And to do this, to dynamically import something, we just say system.import, and then we give it a file name. So in our case, we'll just call it some file. Just some file. And let's go ahead and let's make that file. So new file. And we'll just say hey there. All right. So now we should be dynamically importing this file only when that button is clicked. And it should be button. So we're dynamically importing only when that button is clicked. So let's go ahead and run the build. And before I do that, I think I need to import display button from button. Okay, cool. So let's go ahead and run the build. Oh, and last thing. All right, now we should be able to run it. Let's see what happens. Cool. So Webpack ended up actually generating a new file for us called 0.bundle.js. And I wonder what's going to be in there. So in this case, we can see, okay, so it's uglified and minified, so we can take that out. Can just comment this out. But if we look, we can see, okay, so this is our dynamically loaded file. So Webpack actually saw this. Webpack saw, there it is. Webpack saw the system.import statement, and it said, "Oh, okay, I know the user wants to, the user wants to dynamically load this file. So let me go ahead and create a separate bundle for that. That when the user does click this button, we can go ahead and load. So if this file had like certain dependencies and stuff, Webpack would take care of that as well. So those would be included in the bundle. So if we included, some other file in here, Webpack would know to include that as part of this bundle.js. So that's pretty cool. So let's see if I go ahead and I open my index.html. Let's see if that worked. So looks like we aren't displaying the button. So what went wrong? Export display button. Make sure we export it. And Let's run start. All right, so this should hopefully be loaded now. And there's the button. Okay, a little hard to see, but we'll zoom in. Okay, so here it is. Here's our button. And if we look at the network tab, we can see, okay, we can see we have our bundle. We've got our image, but we don't see that 0.bundle.js file. So I'm going to clear this. And when we click this, yeah, so now we can see that it loads dynamically, which is pretty cool. One thing to note, this system.import, this is an asynchronous call. So if we had like a module in here, so it's system or some file, this is just going to console log something. But if we exported, I don't know, some function, whatever, we needed to know kind of when that asynchronous call is finished, so we could call that function. This will actually return a promise, so it'll give us the module. Then we could do something like module.default if we export a default module. Okay, great. So let's look at something else called vendor asset caching. Which is a big word, but it's very useful for production. And let's take a look why. All right, so in a lot of applications, we have our app code, and then we have our vendor code. So in our case, we've got index.js, we've got our message.js, and then we've got our vendor dependencies, right? So in our case, we just have jQuery, but you can imagine you have jQuery, Lodash, you know, maybe D3, some other libraries. And the reason we'd want to separate them is we very rarely will make changes to a vendor dependency. But instead, we will be, like, for example, jQuery. Like, we're not going to update jQuery very often. But our application code, we're going to make a lot of updates to, especially if it's a new release, there's bug fixes, new features, things like that. We're going to be making a lot of changes. And we can, if we separate these, we can ensure that the user isn't re-downloading our vendor code every time. If we're not going to change it, they don't have to re-download it, especially if it, you know, if it's cached. But our app, we would want them to re-download. So let's take a look and see how we can do vendor caching. All right, so right now I have one entry point, and you saw before in the in that other slide that we separated our app and our vendor code, and we can do this. So instead of specifying a string for entry, we can actually specify an object, and each key for that object is going to map to the output. And the key, and sorry, the value is going to map to the actual the entry. So for our case, we want our output of bundle to map to source/index.js, and we want vendor. We're going to output vendor. And we want that to map to jQuery. So right now we just have one, but you can specify an array of these. So you can imagine if you had like Lodash, you could add that in there. But right now we just have one. And now we kind of have this problem because we have this this bundle, and both of these right now are going to map to bundle.js, and we don't want that, right? We want them to map to this one. We want to map to bundle.js. This one we want to map to vendor. So we can go ahead and solve this by just saying, putting in brackets name, and automatically Webpack's going to replace the name with this key here. So I'm going to run build, And let's see what happens. All right, so we can see we've got two dependencies now. So we've got bundle and we've got vendor. And there's something kind of odd about this. So bundle is 291 kilobytes and our vendor is 274. So we know our bundle is really not that big. I mean, if it's just the files that we wrote, it really shouldn't be 291 kilobytes. So let's see what went wrong. So when we did this, right now, because in our code, we are importing the vendor dependencies. So in our app and bundle, we're importing these vendor dependencies and we end up getting kind of the superset. Our bundle ends up becoming the superset of both our app and these vendor dependencies. And then at the same time, we end up getting these vendor dependencies as well because we specified, oh, I want two bundles, one being our app and one being our vendor. So Webpack provides a plugin called the Commons Chunk plugin. And the Commons Chunk plugin will actually go through the dependencies. It's going to say, okay, which one are common with it? And then you can specify which file you'd want to place the common vendor dependencies into. So in our case, we'd want to put the common ones into a file called vendor, right? So vendor is here, vendor's here. We'd want to put them in a file called vendor. And we'd have a much smaller app or bundle. All right, so let's see how this works. So optimize. So we saw that it comes with this UglifyJs plugin, but it also comes with Commons Chunk plugin. And it's going to take, when we create this, it's going to take some arguments. So it's going to take names, and then we specify vendor. So that's going to be where our code actually goes. So it's going to go into vendor. And then we also need to give it this manifest thing. And this manifest thing is just going to give it, it's going to ensure that our vendor dependency, when we go ahead and we generate a bundle, it's going to know when our vendor dependency has changed and when it hasn't. This is just kind of some extra data that Webpack's going to need, or this Commons Chunk plugin needs. So if I go ahead and I run build, we should hopefully see. Perfect. So we should see now our bundle.js has become much smaller. It's now 13.8 kilobytes. And our vendor.js has stayed the same. It's 272 kilobytes. So our vendor.js, that's jQuery. So that's the big library. All right. So we're not quite there yet. We need to first understand kind of how browser caching works. So when the browser sees a file, so in this case we have some file.js, when it comes here, it's going to check, is it cached? If it is cached, then it's going to load it from cache. And if it's not, it's going to download it. So that's not too tricky to understand, but what we do need to understand is how the browser knows if a file is cached or not. And basically what a browser is going to do is it's going to look at the file name. If the file name is different, it's going to say, oh, I must not have that file. Let me go ahead and download it. However, if the file name has remained unchanged, it will load it from cache. So there's a couple ways to do this. You could kind of increment an index anytime you make a release, but Webpack provides a nice little utility called, or that you could use. So we could do name.chunk hash, and that chunk hash, that's going to be a hash of the file contents. So if we don't make any changes to our code, that chunk hash should remain the same every time. But if we do go ahead and make a change, then that chunk hash will also change. So if I run a build, we should see a set of characters appended to our file. So we can see that our bundle now is 9C60, etc. Same thing with our vendor. So if I go ahead and I make a change, now one thing to note, by the way, is our build is becoming pretty cluttered, our build directory. So we can go ahead and we can clean this up. So anytime I run build, we'll go ahead and remove this directory. So let's run that once more. See what happens. Yeah, so we can see the directory was removed, and now we should just have the files we need. All right, so you can see when I ran this 9C60, that stayed the same. Same thing with our vendor, A6D, right? All right, so if I go ahead now and I change something from our app, let's see if our bundle ends up changing. So we'll go into messages, we'll take out the exclamation point from hi. We're gonna run this again, so we should see our bundle change and our vendor stays the same. Our bundle right now is 9C6, vendor A6D. Perfect, so we can see our bundle is now 062, which means it did change and our vendor remains the same. So when the browser sees these files, it's going to say, oh, the bundle changed. So let me go ahead and load that new bundle file. But the vendor, oh, I already have that. That's cached. So it's not going to bother downloading it, which is great. We can get some really nice savings from this. All right, so one thing to note when we go over here is let's try and open our index.html. We can see it's blank and it's saying file not found. It's looking for bundle.js. And that's a problem because our bundle right now is a totally, we can't really know what this is going to output. So we don't really want to copy and paste it every time. So there is a plugin called HTML webpack plugin. So it's going to be a dev dependency HTML webpack plugin. I'm going to install that. And I'm going to go ahead and require it in HTML. Okay, and we can now instantiate it, new HTML webpack plugin. And this can actually take a template. So the template is going to be our HTML. So it's going to be this index HTML. And since now we're kind of modifying our index HTML, let's go ahead and remove it to source. And we can go ahead and remove this script tag now because this new plugin that's going to take care of all the script tags that we need. So our template is going to be in source/index.html, and it's going to end up doing some processing on it. So remember, it's going to be like the post processor. So after our bundles are generated, this HTML webpack plugin is going to go ahead and it's going to be like, okay, what are the outputs of those files? So it's going to look at the bundle output and it's going to look at the vendor and it's going to then inject those into our HTML script tag, which is pretty cool. So we don't have to go ahead and manually update those with those new chunk hashes. And one other thing I'm going to do is, since it's going to put our index HTML, after it processes it, it's going to go into build. We're no longer going to need this public path because it'll know basically, okay, it's kind of wherever the index, it's relative to wherever the index HTML is. So everything will be in the same directory. And you'll see now if we run build, we remove our old stuff. And there we go. So now inside build, we can see we've got all our files and we also have this index HTML. If we look at it, we're going to see the manifest, but we're also going to see our vendor and our bundle, right? So now these are included, and they have the chunk hashes that we want. So like our bundle 0, 6, 2, 5, it's got all that stuff on there for us. So no manual work needed. And let's go ahead and open now our index HTML. Now we need to open it from build. Index, there we go. Perfect. So it still works, which is awesome. All right, so now let's look at a new feature that Webpack has called tree shaking. So tree shaking is kind of neat. Webpack out of the box, it supports ES6 module type syntax. And a lot of times we end up importing things that we don't end up needing. So let's take a look at our image display here. So you remember we had these files display cheetah and display sloth, and we're exporting both of those. But if I look at index.js, you remember we ended up moving that removing that display cheetah function. So right now we're importing actually both of these functions, display cheetah and display sloth, but we're only using this one. So this code up here never actually gets used, and it just kind of sits there and takes up space. So what tree shaking allows us to do is it's going to remove any unused exports, which is pretty cool. So how it works is it's going to first remove the unused export, and it's going to keep that function there. So it's going to remove the export statement that we have here. So in our case, display cheetah will not be exported. And then after that, it's going to, when we run like UglifyJs, it's going to see that, hey, that display cheetah function, that's not being used by anyone. And UglifyJs will automatically remove any dead or unused code for us. So it's pretty cool, and it's kind of a new thing. So let's see how it's done. So remember, it does come out of the box for us in with Webpack 2. But one of the problems is this ES 2015, or when we run Babel, it's automatically going to transpile all of our modules from ES6 syntax to CommonJS. And unfortunately, Webpack's only going to do tree shaking with ES6 type modules. So we can get around this by just saying modules false. Okay. And before I go ahead and run this, I want to show you real quick the cheetah display cheetah. So we can see that it is being exported, and the function is there. And yeah, so it is being exported. So let's see what happens now that we've basically allowed, so we've removed the transpiling of modules. So now Webpack 2 should just work out of the box with tree shaking. All right, looks like we got a problem here. Let's see what it is. Lodash. Oh, you know what it is? This should actually be an array. Yeah. Okay, so that should work now. This thing needs to actually be an array, not whatever I had it before. Okay, looks like that worked. Let's go ahead and open that file. So we can see display cheetah. Okay, so we can see that it's actually still there, and that's okay. So remember, I said that Webpack is going to kind of work in two steps. So it's going to go ahead and it's going to remove the export. So we can see it's no longer being exported. It's going to say unused harmony export display cheetah. But it is, however, the function is still there. So when we go ahead and do this in production, we're going to end up, the UglifyJs is going to kick in, and it's going to end up removing this function altogether, which for us is actually pretty cool. It should give us a nice, it's not going to save us a ton, but you could imagine, if you have a bunch of these unused exports in your code, it could save you a pretty significant amount. So I'm not going to run it. I'm not going to do it in production, but I will say that if we come back here and we re-enable UglifyJs, that function will be gone altogether. All right, so last thing I wanted to show was, so now we've added a bunch of modules, we have jQuery, and we at some point it might be a good idea to see, okay, what, all these things we're importing, etc. What's all this stuff look like? What's my bundle look like? How many, how big is it? How big are all my modules? Where's any kind of bottlenecks? So when Webpack generates or runs, you can generate a stats file, and that stats file can be used. Since it's kind of going through, it's creating a dependency graph of all of your modules. I mean, it's got a bunch of data in there that you can leverage to kind of visualize what's going on. So one of the plugins that we have is called webpack-dev-server plugin. And while that's installing, we can go ahead and we can require that in. So webpack-dev-server plugin. And down here, we can basically just say new visualizer. And then one thing I'm going to do over in my package JSON, we're going to say, create a new script called visualize, and it's going to do, so when this plugin ends up running, it's going to create a file called stats.html. And we can open that from build/stats.html. Let's see what happens when we run this. npm run visualize. All right, so this is the output of it. So we can actually see that this contains a visual representation of all of my modules. So in here, this kind of big guy, you can guess it's all coming from node modules. So this is going to be jQuery. So this is the jQuery, and this much smaller one here. Well, that's actually our that's our code. That's our app code. We can see it's much smaller than our vendor dependencies, which is very important. So we talked about vendor caching. You can see how much bigger our just one vendor dependency is compared to our app. And over here in our app, we've got our cheetah. So this is as large as it is because it is a data URI, which ends up becoming pretty large. Our sloth is just a file that gets imported, so it's much smaller. And then you can see, these other files. I mean, they're very small. There's almost nothing in them. Cool. So that's pretty much it. That's all the things that I wanted to go over for Webpack 2. If you have any questions, feel free to add a comment in the description, and I will be sure to answer it. Thank you for watching.